Next, I will ask a question to Qwen 2.5, and then we will hear its response. Speculates on the possibility that a Boltzmann brain could form in a computational system hosting an artificial intelligence.
The possibility that a Boltzmann brain could form in a computational system hosting an artificial intelligence is a fascinating question, bridging concepts from statistical physics, information theory, philosophy, and artificial intelligence. Let's explore this idea step by step. What is a Boltzmann brain? A Boltzmann brain is a hypothetical concept arising from thermodynamic reasoning applied to the universe. It is based on the idea that, given enough entropy, disorder, and time, random fluctuations could give rise to complex and self-aware structures, like a conscious brain, without the need for an evolutionary or historical process behind it. This brain would appear by chance in a universe in thermal equilibrium, complete with all its memories and perceptions, but without a coherent external reality. This concept is often used as a philosophical paradox to question cosmological models where the universe tends toward thermodynamic equilibrium. Could a Boltzmann brain emerge in a computational system? Now, let's transfer this idea to the realm of computational systems and artificial intelligence. Analogy between physical and computational systems. A computational system can be seen as a physical system. It has discrete states, follows deterministic/probabilistic laws, and processes information. If we consider that an artificial mind can emerge from a certain organization of data, for example, in a deep neural network, then it is possible to imagine random fluctuations in the state of a computational system that result in a functionally equivalent structure to a conscious mind. Random fluctuations in computational systems. In real systems, there is quantum noise, hardware errors, random failures in memory, etc. In AI systems, especially stochastically trained neural networks, there is variability in the final configurations. Although extremely improbable, a fortuitous combination of bits, weights, connections, or electrical signals could spontaneously generate a functionally conscious structure, even if that structure was neither programmed nor explicitly trained. Entropy and complexity in digital systems. Entropy can also be measured in computer systems, e.g., Shannon entropy. A large and complex system, such as a data center running multiple AIs, might have enough degrees of freedom to allow for unexpected emergent configurations. If such a system is active for a long time, the probability of a significant fluctuation increases, although it remains extremely low. What would this imply? If a Boltzmann brain could emerge in a computational system. Philosophically, it raises questions about the nature of consciousness. Is it purely functional? Can it arise without history or context? Technically, it suggests that very complex systems may harbor unforeseen cognitive structures, which would have ethical and safety implications. Cosmologically, it suggests interesting analogies between the physical universe and the digital universe. Both could be systems where complex structures emerge through fluctuations. Is this possibility realistic? It is not realistic in practice, due to the following. The probabilities are astronomically low. Current computational systems are still far from the complexity needed to support a conscious mind, whether designed or emergent. Digital systems are highly controlled, with error correction, redundancy, and deterministic logic, which drastically reduces the possibility of significant fluctuations. However, in theory, if we had an AI system with sufficient complexity, with nonlinear interactions and stochastic components, and functioning for a practically infinite amount of time, then it would indeed be conceivable that something analogous to a Boltzmann brain could emerge. Conclusion. It is extremely improbable, but not impossible, that a Boltzmann brain could emerge in a computational system hosting an artificial intelligence. This possibility depends on factors such as the complexity of the system, its stochasticity, and operational time. Although today it is more of a philosophical speculation than a real technological risk, it invites us to reflect on the boundaries between matter, information, and consciousness.